Thank you for joining us today. Without further ado, please allow me to welcome Mr. Dipayan Sarkar. Dipayan is the principal data scientist at Algorithmo Labs. Prior to Algorithmo Labs, he has worked in Maersk Group as a data scientist and Apple as a business intelligence consultant. He has completed his master's in economics. He is currently pursuing a PhD from Reen School of Business. Additionally, he takes courses on Python and big data at Masters in. So without much ado, I would like to pass it on to Dipayan to take this further.
Thank you, Abhishek. Thank you. So here we are going to talk today about natural language processing. And we will also see how we can use natural language processing in different domains. So have we ever wondered how some of these things which you see on my screen work? When we get an email, the email gets into the spam box if the email is a spam. And Gmail does it pretty effectively. Why Gmail? Almost all mail services, they pick up the spam mails, put it in the spam folder. But how does it do that? When you're typing something on your phone, it predicts the next word you are going to type, and it gives you the options. Personal digital assistants. Nowadays, we use Siri, we use Alexa, home products, and we instruct these devices to follow certain instructions from our side. Chatbots. If we visit, any websites, insurance websites, or any product websites, banking websites, the first thing today we get it is a chatbot, which wishes us and says, "What do I need?" Solutions like Grammarly. It not only corrects the grammars, it also suggests the right or alternate words that can suit our whatever we are writing. Plagiarism check. It does it in few seconds and minutes. When we are typing our email in Gmail, all of you must have noticed that it suggests the rest part of the sentence. It predicts what you are going to write. You just press a tab, it writes it for you. Life is so simpler and easier for us. Information extraction. Please note, we are not talking about data extraction here. We are talking about information extraction, which means data is there everywhere. How do we pull out the right and the relevant information for us? Sentiment analysis. The world is talking about sentiment analysis, whether it is a customer feedback, whether it is an email from a customer, whether it is a Facebook post or tweets. People are running after saying, can I analyze the sentiment of these posts? Can I answer to questions? Can I respond to human beings? Can the machines respond to human being queries? Translation. Most of us have used Google Translate. Translation. Now, if you notice, all of these services, they all use NLP, the natural language processing. Let's take a look at some of the applications of NLP for marketing before we get to see how NLP does this for us. To start with, we see here AI Copywriter for efficient ad and content generation. It might be surprising, but yes, many companies are using NLP for writing contents, for even writing ad materials for them. Take this example. One of the Harley-Davidson dealer in the US was selling 2 motorcycles per week, just 2. And he encountered with a solution called Albert.ai. Well, I'm not promoting Albert.ai here, but this Albert.ai was referred in this case study. And after using this Albert.ai, what it does is for you is it suggests the social media posts, the ads. It keeps track of how people are reacting to the ads, what kind of comments being put against the ad and the social media posts and so on. And to the surprise of the dealer, what happened is it picked up the past ads the dealer has put. For example, don't miss out a pre-owned Harley with a great price, buy now. And this tool suggested replace the word buy, instead have the word call. And the ad turned out to be, don't miss out a pre-owned Harley with a great price, call now. And with this one single change of the word, the ads performed 447% better. Imagine, even as a human being, we might not have thought of replacing the word buy with call. Of course, we are more creative than a machine. Of course, we are. But sometimes we might miss out a single word. And this tool was able to, understand the social media posts, the reactions, the actions on the social media posts. And it suggested that replace the word buy with a call. And the result is in front of your eyes. Talking about other tools, for example, Chatbot. Now, when we go for some insurance websites, some product websites, you want to purchase something, you go to a banking website, chatbots come and wishes you and says, what do you need? But it is not just what chatbot is doing. Chatbots are doing much more. It is able to comprehend what we are talking with it, and it is able to prioritize the messages. It is able to forward the right leads to the right person. And it is obviously contributing in increasing sales, right? Next is the sentiment analysis. Sentiment analysis has been used for many years now. We have been trying to find out the sentiments on tweets, finding out the sentiments on Facebook posts. But when it comes to marketing, it has a number of interesting use cases. For example, brand monitoring, competitive research, product analysis. How is the market? How is the consumers? How are the consumers reacting to a new product? What is the sentiment, right? This is what all sentiment analysis can contribute to the marketing space. Voice search, it's gaining wider acceptance. Currently, you will be surprised to know that 65% of people who are aged between 25 to 50 speak to their smart devices at least once a day. At least once a day. And it is estimated that more than half of the online searches will use voice in a year or two, making voice an essential platform for the marketers of tomorrow. Because till now, what Google has been doing is crawling all sorts of text materials, textual data to give you the information. Now it is the voice. All the voices are recorded, voices are searched for, converted into texts, a lot of analysis being done on it, and all the marketers are being aided with it. Automated summarization of information. Well, we might say it's just automation of summarization of some information. What's the big deal? But let me tell you, the state-of-the-art text summarization approaches enables the marketers to extract exactly relevant content about their brand from online news, articles, and various other sources. So basically, I can say that if I can get an automated summarization of some information about my product on daily basis, I'm basically being informed about the trends of my product in the market, right? That's awesomely useful. So if you see in the marketing space, NLP is set to continue being one of the main go-to AI technologies for marketers, with applications ranging from your trend identification and summarization, content and ad generation, conversational lead capture, and all of this can support the marketers in various ways. But then how does it work? It's all about textual data. It's not a structured data. If we have a structured data in Microsoft Excel or in some databases, it's pretty much easy to use. But how is it possible for a computer to understand this textual data? It's unstructured data. It's a human language. And you are expecting these computers to understand this human language. But how does it do? So what it does basically is it takes this unstructured data, encodes it, and gives it to the computer. Now, this NLP is an umbrella term and has two key components. One is the NLU, which you can understand, is the natural language understanding, and the other one is natural language generation. How are these two components different? If you see, NLU is all about reading the stuff, reading the text, reading the data, understanding from it. NLG is all about writing. You understand and then you generate texts, right? These are the two main components. So let's deep dive a little bit on the NLU part of it. It has two main components, again, the syntactic analysis and the semantic analysis. So syntactic analysis, it parses and analyzes text using basic grammar rules to identify kind of structure. So it identifies the grammatical structure of the sentences. Semantic analysis, on the other hand, it focuses on capturing the meaning of the text through combination of words or even through context. For example, if I tell you that John is boating against the current, what happens is John is riding a boat against the current. Here, the current is a noun and the boating is a verb that precedes the current. Because we are able to comprehend this very efficiently, we understand that this current is nothing but a flow of water. On the other hand, if I say the current version of this document is in the folder, you are able to comprehend that, well, this current is not the same as the previous current. This current relates to maybe the most up-to-date version of the document. And this is what the semantic analysis can do. It can capture the meaning of the text through combination of words and through context. Next, let us take a look at the NLG part of it. It has, again, two components, the text planning, the sentence planning, and the realization. So it formulates all the words in a logical manner. It considers punctuations, pronouns, conjunctions, paragraphs, and it ensures that the grammatical rules are in place. And that's how NLG can actually generate text for you. NLP has a pipeline, which means it has many sub-processes. And while there are many complexities, these are some of the processes that your textual data, before even this unstructured data, before being processed or before being fed to the algorithm to do some actions, it goes through some of these processes in this pipeline. So we see here segmentation, tokenization, stop words, you have stemming, lemmatization, the speech tagging, the named entity recognition. These are some of the sub-processes that your data goes through, in order to be consumed by the algorithm for some actionable things to do. Well, these are some jargons, but these are actually simple things if you see. If you see the segmentation, I have a sentence here, India needs to spend 6% of its gross domestic product on education, comma, every natural education policy since 1968 has said. Now, what the segmentation will do is, based on the punctuations available, it should be able to segment the sentences. So you see here down, it has segmented this complete paragraph into two sentences, right? The next, once the data is segmented, it goes into the tokenization process. Tokenization is nothing but breaking your sentences into words. So India needs to spend 6% and so on has been broken into separate words, and this is what your tokenization is. Stop words is removal of words which are not really necessary to comprehend. For example, to, off, it's, on. These are some of the words which are known as stop words are removed by the process. In fact, if you go to Google and you type something to search, it ignores the, on, in, and such words, right? So those are the kind of stop words. Once you have these stop words, it also takes a look into something called stemming, where it stems the different words into its base form. For example, here you see, I went to his house yesterday, but will be going again tomorrow. Will you also go along with me? Now, there are three forms here: went, going, go. And the stemming process brings everything into the base word called go. Lemmatization is a similar thing, but it works on verbs like am, is, are. I'm going to visit the child. John is coming with me. The other boys is also coming. It takes up all of these words, am, are, is, brings into the base form, be. Speech tagging, another interesting thing. If you see, I will visit the Himalayas, what it does is it picks up each of these words and associates the parts of speech, the part of speech with these words. So I is a pronoun, will is a verb, visit is a verb, and so on. And it is able to do this kind of works very effectively. And then you have named entity recognition. The name suggests that it is able to detect person, it is able to detect organization, it is able to detect place name, product names as well. So when I said Steve Jobs is the founder of Apple, it says like Steve Jobs is a person, Apple is the organization, right? If you go and say, okay, Steve Jobs is the founder of Apple and iPhone is the flagship product of Apple, here it will identify iPhone as the product, Apple as the organization, Steve Jobs as a person. And these are some of the things how NLP actually processes your unstructured data. Now, there are language models, but what are these language models? Very simple, like, you take textual data, you build some models on it to perform certain things. For example, sentiment analysis is one of the things you do, right? You build a model on your text data, and that's what your language model is. So language models, you simply use some ML algorithms with which you can recognize, you can predict, and you can generate human languages. But then what is large language model? Well, simplistically speaking, if you build this language model on a voluminous data, that is what a large language model is. But then why are you talking about large language model? Is it that if you give me a large volume of data, I will not be able to build it? Well, yes and no, because the volume of the data that we are talking of is mind-boggling. It's not another large data. It is voluminous data. And many of us must have heard of machine learning nowadays. So what does this machine learning do? This machine learning algorithms, they take the past data, find out a pattern, build a mathematical model, so you can use it, for predictions or for classification problems. Now the question comes, how much past data can you get? Well, of course, you might say, yes, I have some quite a high volume of past data. Now think of something. Think of a computer vision model where you are expecting the computer to, detect an object and identify an object. So if you show an apple to the computer, it should be able to say, well, it's an apple. Now think, you have so many different kind of objects and flowers and fruits and animals across the globe, right? How do you actually use them? You don't have the images of all these objects with you. And even if you have, do you have the computational resources to build such a model? The answer is no. So as an individual or as a small organization or small company, they might not have such kind of resources available with us. Here is where Facebook and Googles of the world, they came forward, they collected all this high volume data because they can afford to do it. They have huge computational resources and they have built this model. And they said, well, now that we have built this model, you really don't need to build them from the scratch. Instead, this is the model we have built on a very high volume data. You use it for your purpose. And in addition to it, you can also tweak it. It's not that you have to use what they have given. You can also have the flexibility to tweak the model to use it for your purpose. And this is where the large language models are coming, where various companies like Microsoft, OpenAI, co-founded by Elon Musk, Facebook, they have come up with large language models. So some of the large language models which you see here, one that stands at the top is the Megatron Turing NLG, co-developed by Microsoft and NVIDIA. It has 530 billion parameters. If on a simplistic side, if I have to think on a very simplistic side, I will say, okay, it means it has used 530 billion words. Okay. The next is the GPT-3, 175 billion parameters. These are not matter of joke. It's a huge volume of data. GPT-3 is formed by OpenAI, which is co-founded by Elon Musk. And of course, given the number of parameters, there is a big difference between Megatron and GPT-3. But the good part of the GPT-3 is they have extended the API for normal users like you and me to use it and try it. So they call it a playground. I will just show you in a while. Now, this challenge is there are some challenges with the language model. While, of course, these language models can do wonders for you. They are able to write contents on behalf of you. There are some misuse is happening across the globe. Like, for example, if you see the screen, college kids fake AI generated blog fooled tens of thousands. And if you see the line next to it, it was super easy, actually, he says, which was the scary part. Yes, there is no dirt to, misusing such kind of tools. There are examples of where GPT-3 is used for generating fake news, for generating emails and sending such emails to the recipients. And you know what? These contents, even they are fake, one is not able to distinguish from the original and the fake. They are not, it's not distinguishable. GPT-3 is working so well. So we need to stay concerned about using these things very properly. And we also need to stay concerned about these things being not used properly on us. And as with data, with any kind of such AI technologies, there is always another challenges. We need to stay ethical. So I'm not sure if you have heard of this. Amazon, what Amazon has done is Amazon has used NLP and machine learning to score their resumes. So Amazon was getting high volume resumes and they had to, filter each of these resumes manually. So they decided to build an AI tool using machine learning and NLP to score the resumes. But what this model did was, this model was giving very low score and downgrading all the female resumes. Now, you might say, well, in the resume, I don't say I'm a male, I'm a female. How is this possible that, this tool is able to understand the female resumes and the male resumes, right? So it was picking up words like, St. Joseph's Women's College, or maybe New Jersey Women's Club, or maybe I have won the Women's table tennis championship. These kind of words were being picked up by the model, and it was downgrading all the female resumes. The news were everywhere, starting from Reuters to New York Times to BBC and everywhere. And Amazon had to come forward and say, look, we have not used this tool. So in addition to the regulatory legal compliances, misusing or wrong usage of this kind of tools can also lead to social and moral challenges, right? So let's take a look at this GPT tool. It's a pretty interesting tool. Let me show it to you. Do you see this? This is actually a playground, which means the GPT-3, the large language model, which I was talking about, is has given the API, exposed it to us to use it. And on the right-hand side, if you see, on the right-hand side of the screen, if you see, there are a lot many parameters, like which model you would like to use, how many words you would like to generate. And I can really simply increase it to any number of words. And here is what, let me try. Write maybe a poem on Gurugram. And this is what the NLP model generates for you in a few seconds. It might take a bit of time. Wow. It says, the city that never sleeps, the city of concrete and steel, the city of malls and office blocks, the city that never stops, city of honking and pollution, never slows down, the city of Gurugram. So if you see, it becomes very tough for you to realize that this is written by an NLP model and not by a human being, right? And you can write almost anything. Even there is an API from GPT-3 where you can write science topics, scientific journals. It will go through the web, scroll everything, scroll multiple science journals, consolidate them, aggregate them, and write its own science journal in such a manner that it becomes really tough to segregate or differentiate and say, well, this was written by GPT-3 and not by a human being. Well, that brings us to the end of this presentation.
That was a very insightful presentation, Dipayan. I think myself and all the attendees have thoroughly enjoyed the presentation. So we have a few questions. So Dipayan, so we'll start off with a few questions that we have from the attendees, and I personally also had a few questions. So I'll just start off with that. The first question is, I think we all now understood, NLP, and we know the basics of NLP. We know that, where NLP is being used for. So the first question that we have from the attendees is, what are the tools available in the current industry that can be used to implement NLP?
Well, there are two things to look into NLP from two different perspectives. Okay, one is like, I want to build something from scratch. That is like if you ask me, I'm passionate about building something from scratch. But on the other hand, there are business houses who would come and say, hey, I don't want to build something from scratch. I want to use something. Right now, if you want to build something from scratch, there are many Python libraries that are available. There are many, just simply not many. Spacy, NLTK, Gensim, you name them, and it's like you have a handful of libraries to develop something from scratch. On the other hand, if you would like to use certain software as a service, or rather, I will call it AI as a service, right? AIAS. The first thing that comes to the mind is IBM Watson. You have GCP, Dialogflow. You have AWS services. You have Azure services. Apart from these named and the famed ones like IBM, Azure, AWS, and Google Cloud, you also have many startups. For example, the case study which I've referred to, like Harvard Business Review, right? This case study, how the Harley-Davidson dealer has used Albert.ai. It's just wonderful. I can't even imagine Albert.ai as a solution coming and saying, replace one word in your ad and it will change everything. This guy who was selling 2 motorcycles a week is now selling 15, right? So coming back to your question here, this Python is one of the tools which you use it if you want to develop from scratch, or you use AI as a service from different service providers.
Right. I think that would be very insightful for people in the webinar and people who are interested to implement. And I personally also feel that it basically depends upon the use case. And it also depends upon the timelines, right? So if I have good amount of time, I might want to learn NLP from scratch and implement it using a Python or an R, whatever language is suitable for my team. While in case if I don't have the time bandwidth, I can go for the tools that was just stated, that IBM Watson can be used. We can use Google services. We can use Dialogflow, and that's the way in which we can implement NLP. Thanks for that.
I would like to also add one point to it, like if you are a new learner, right? It might also be good to learn some of these things, how to do it, and then use the AI services. AI services is always there at your disposal. But if you also learn a bit about how to do it, you need not be a complete master in everything. But understanding how these things are working can also help you choose the right tool.
Thanks for that, Dipayan. So we just have a quick follow-up question from Harish in the attendees, as to they want to learn how to learn NLP from scratch. On what do they refer to?
Okay, so I would say, like, there are many free resources available today, including Coursera and Udacity, like MOOCs, and you also have quite a good number of courses in Udemy, which are like short courses, cost-effective ones. Maybe that can be a good start, and once you get a momentum, then of course you can enroll for a more complex courses or something. And of course, Google is always there. There's many materials to learn NLP today. But if you are planning to do it from scratch and you have some technical background, definitely exploring Python and its libraries for NLP would be a good choice.
Thanks for that, Dipayan. And I think Harish, you would be taking up further. And so now I come to second question that spring up from my mind when I try to understand the session, right? So the first use case which comes to my mind is Alexa, right? Amazon Alexa is so I wanted to have your insights as to whether Amazon Alexa is sort of integrating NLP, and what is the high level sort of understanding as to how Alexa is working along with NLP.
So first thing is internally, it has a lot many capabilities like voice to text, right? And text to voice kind of stuff. And it is able to even take our voice, convert it into text, search those texts in Google, get the replies, and then change the text to voice, and again, speak it out back to you, right? These are some of the things that Alexa can do. And in fact, not only that, of course, this might not be a part of the NLP to some extent. Of course, it's a part of the NLP as well. Like when you say, hey, Alexa, switch off the light or switch on the light, right? Even I have a light at my house, which where I use Alexa to say, Alexa, can you put the light to 50%? And it dims the light, right? So this kind of IoT integration can also happen. So it takes the instruction, does the kind of NLP stuff, and then interacts with the other IoT devices.
That's good. So I got to understand that, okay, today how Alexa actually works and we have been using Alexa, but yeah, getting to know how it works is actually, is mind blowing. So we have a question, I think follow-up question by one of the attendees. So I'm just skipping to that question. So the question is NLP the neural network built out of Python, is what the question.
First thing is, let's understand this. NLP is more of a process. It's a concept, right? Natural language processing, which has two components, the NLU and the NLG, where it reads and understands the component, and then it can generate the content, right? Now, neural network is an algorithm, all right? Now, this neural network algorithm can be written in Python, can be written in R, can be written in Java, can be in any language. So it has nothing to do with only Python. But yes, Python has a lot many libraries on different flavors of neural network, and that can give Python an added advantage over R or over certain other software. Coming back to the algorithm now, so Python is only a tool. Neural network is the algorithm. Now, there are different flavors of neural network. For example, I would like to say that recurrent neural network. Recurrent neural network is a flavor of neural network that can generate or understand the sequence in the text, right? And in fact, now when you read, when human beings read, we read it only in one direction, right? Whether it is from left or right to left, we read in one direction. For example, the question here is NLP is the neural network built out of Python? I will read it in one direction. This recurrent neural network can read it in the sequence in one direction. You also have algorithms which can read bidirectional, and that is like LSTM, another flavor of recurrent neural network. So now these neural network algorithms like recurrent neural network, CNN, convolutional neural network, LSTM, the long short-term memory. These are the algorithms that can be used to generate NLP kind of solutions. So you are talking about three things here. One is the Python as a tool, neural network as the algorithm, NLP is a kind of solution. Does that answer your question?
Yeah, I think, yeah. So thanks for responding back, Ashish. And I think that should be pretty clear now as to how we, implement. And, Python is basically the interface or the tool that is being used to implement, and NLP becomes basically the algorithm. And finally, we have the neural networks, right? So,
so I can also do, for example, sentiment analysis. I can do sentiment analysis with a Bayesian algorithm. I don't need neural network. And I can implement Bayesian algorithm using Python or using R or using SAS or using SPSS. Doesn't matter.
Right. It just becomes a medium.
It also depends like what problem you are solving using NLP, and some problems will definitely require neural network. Some problems might not require neural network. Some problem might be solvable with some other algorithms, like as I said, like Bayesian algorithm.
Thanks for that, Dipayan. We'll move to the next question now that we have. So next question is, as a report, businesses, lose as much as 20% of revenue due to poor data quality. A major use case comes into marketing and which I can relate to is market research. So when we, undertake qualitative research, we generally have a lot of textual matter, and where I feel NLP would be a very good, way to understand what is sort of, inputs that have been given by survey users for a particular survey, right? So what are some of the best practices in the industry to ensure that the quality of data is good? Because that is very, very essential for my analysis to speak out the right words.
Well, that really depends on, that might vary from organization to organization and problems to problems, right? So it also depends on what problems you're trying to solve it. And then the way the data is stored or sourced, rather. Either are you sourcing it from the web, or are you sourcing it from your own organizational repository? Now, if you are sourcing it from your own organizational repository, so for example, NLP is extensively used in healthcare, extensively used to dig into the medical records, compare medical records of different patients, coming up with solutions or prescriptions. These are extensively used. Now, as I said, information extraction. Now, if you are extracting this information from the web, you need to be extra cautious because there is a lot of fake news today. There are a lot of wrong news as well. For example, if I don't want to name some websites, but there are many websites where general people can go and answer to a particular question. Now, you can't validate those questions, those answers, whether they're right or wrong, right? So in those kind of cases, definitely you need to have a sanity check to say, yes, these are the things which are pulled out from the web and we have validated it. Secondly, if it is from the organizational repository, you can be pretty much assured, yes, this organization has maintained their own policies of storing the information, and it has to be the same. So while now then, when you gather this information, you keep in mind two things. One is the relevancy, how relevant it is to your business problem, and the context, because some information can be relevant but might be out of context also. So you need to ensure that the relevancy, the context is all in place.
So what so then the key learning which I took from your answer is it all depends upon the business case, and it all depends upon how critically an organization is storing and using it. And therefore, I think the key thing over here is to ensure that the data quality is in place and we get good insights. Is the business logic around why the data is being stored, how is it being stored, and ensuring, and it becomes an organization's responsibility to ensure that the data and the way in which the data is getting stored is stored in a proper manner. So
Yes, and to an extension, when you said like it is the responsibility of an organization, if you remember my slide on Amazon, it has become Amazon's responsibility to say that, yes, we have taken the last 10 years or 15 years of data, and we have taken the data for a particular sector, and probably male people were dominating that sector, and we shouldn't be using this data. Right? So Amazon has stopped using it. Just because you don't have the right data doesn't mean you can go ahead and build a model and use it, right? So even if your data is relevant, even if your data is contextual, you need to very thoroughly understand whether you can use the data or not. You should keep in mind the legal, regulatory compliances, social and the moral implications, and then decide whether you can use it or not. So it is not only an organizational responsibility, Abhishek, it is your and my responsibility. So as an individual, what I mean, we are very, very, very responsible as a data scientist, data analyst, or even as an individual employee who might be a stakeholder in this process.
Right. I understand that, Dipayan, and I totally, understand and agree with this point because, I earlier before doing my master's, I was basically working in a bank as a data engineer, right? Mm-hmm. So there we used to have a lot of questions around, okay, what sort of data is being stored, and we used to basically go to multiple, stakeholders to get approvals to use, customer data. So there we used to generally have these questions around, what is the data that is being used, whether the data is, is something called a PII data, whether that data allows me to personally identify some person, right? So whether that data is actually required for a particular use case, right? So I, as an engineer, I, as a data scientist, I am totally responsible to answer those questions to the stakeholders in the right fashion, so that the organization can take a decision as to whether and how the data is to be stored. And if in case some data maybe is being used for some process or some analysis, it should be duly communicated to the customer that yeah, so and so data has been used, and getting permissions
Right.
sought out from the customer, right? So that's where all of this GDPR also comes into picture, where the regulation comes into picture, and all the central banks and all the central banks of all the big of all big countries, right, they state out rules. But ultimately it's up to me, or up to an organization, whether the rules and the regulations are properly followed. Thanks for that answer, Dipayan. Now moving over to the next question is, with the advent, so just a follow up to this question, right? So with the advent of digital era, wherein customer data is leveraged, and data driven decisioning is a very important aspect of any organization operating. So we keep hearing that data is the new oil. We are leveraging data, and we just understood that, okay, how critical it is and how important it is for organizations to ensure that data is stored in the right fashion. What are some of the best practices in the industry to ensure that customer data isn't compromised? Especially, we spoke about healthcare, we spoke about banking, where customer data becomes very important and useful.
Well, again, that depends on the organizational policy and the way you provide access to the right individual. You provision the data, not that just because I'm a data scientist or somebody, I need to have access to all the data. It's not that. It also depends on the roles we play. So everything again boils down to the organizational policy, how the data is being provided to each individuals, and how this information is restricted from being leaked out, right? So those are some of the
right. So I think then it depends upon whether a particular user requires a certain access or not, and
exactly.
ensuring that the policies in an organizations are properly maintained, and the bigger stakeholders, or even the leads of particular companies ensure that only the right amount of data is exposed to a particular person working in a process. I think that, and if that is followed, the proper policies are set up in place, I think data will never be compromised, and we can be in an idealistic world. But obviously, there are certain ways, and we heard what we just saw a few years back when Capital One data was there on AWS, and it got. So there are obviously there are bits and gaps, and these are, I think, good use cases for us to understand that, okay, where and when data are getting compromised, and what are some of the best practices that companies should adopt to ensure that data is
Exactly.
right in right place, right? So now I move over from this topic of data security, excuse me, to a topic where we just spoke about you know data being leveraged by Google and Facebook, where we just understood that they're storing huge amounts of data, and finally we as customers, or we as users, or we as engineers can basically not create our own models, rather refer to the models already built in, because these data are sourcing huge amounts, these companies, sorry, are sourcing huge amounts of data, right? So that's where I think a crucial component comes into picture, which is currently in the market, right? That's cloud, right? So, what is your opinion about, companies using cloud? Because I think one important factor which becomes is, as soon as I move my data from my own ownership to a cloud platform, right? I might not have that much of access, or I might not have that much of direct access to it, because I don't own it directly anymore, right? So I just like to hear your opinions around the same.
Well, I'm not a cloud expert, but I have been working with various organizations, and I see that most organizations have taken a hybrid cloud strategy. For example, if I resort to cloud A and I've moved all my data to cloud A and I've been using all their services, I have developed my applications built on their services and all this. Tomorrow, if I feel the need to move from cloud A to cloud B, I won't be able to do so very easily because we are tightly coupled with these cloud services, right? So they have started, most companies have started strategizing hybrid cloud, where they say, okay, we have a private cloud where we store all the data. We use the public cloud where we can push the data, not the whole data, but some of the data which we require for computations or some kind of, computations. So we put that on the public cloud, we do the computations, we use the services and resources and bring it back to our private clouds. And even companies have started strategizing using different public clouds altogether. For example, maybe AWS, suppose, I'm just giving an example. Suppose AWS has very good storage services, whereas Azure might have good machine learning services. So companies have started using storage for AWS, ML for, Azure, some kind of data, confidential data storage on the private cloud, and they have started a hybrid cloud strategy.
Yeah, right. So I think that totally answers this question, because it is very important and essential for us to have a backup strategy, and also to ensure. So now we have so many tools in the market. Like I think you just spoke about various tools in the NLP services itself. So we have IBM Watson offering chatbot services, while we also have GCP offering its own chatbot services, its own ML services. AWS is offering its own sort of services. So to understand that, okay, what is my use case and where it is aligned to, right? That becomes critically important, and ensuring that we use the best services available to us for the right use case, right? So now we had a lot of discussions around data privacy. We understood, and we also understood that, okay, what is the best practice around data privacy, and how we scale up data. Now the next few questions that that again came in my mind during the session was, we understood one critical aspect of NLP is Grammarly, right? So the question from my side is that we understand that, okay, using multiple techniques. So we have the segmentation, tokenization, stop words, streaming, right? All of that, and all of this suite is basically enabling me to improve a particular word, or maybe write a particular word, right? So and grammar has a lot of rules, right? A lot of set of rules. So my question is, how is it fed up and how is it ensure that it's updated? Because there are a lot of rules which come up, and it's updated, right? So how does the whole process work as to feeding a rule into a rule book, and ensuring that that responds back correctly?
That is again, it depends on the language grammar structure, because if you see the grammatical structure also varies from language to language, right? And even not just the grammar, the punctuations and the pronouns, the way it is used completely varies when you cross across different languages. So again, given on the past data, these models have been fed, the model is able to learn this kind of syntaxes and the structures mainly. That's how it does it. And this punctuations and the grammatical structures, as you rightly said, is very, very important, right? Because one small punctuation can change the meaning of the sentences. Right. So yes, these models needs to be refined with time. There has to be different models for different languages. In fact, there are different models for different industries, even if it is in English. If you are working on the extraction of the legal records, there is a different model being built for it. If you are extracting healthcare records, there is a different model being built for it, right? So it all depends, again, coming back to the business problem you try to build, you address. So you feed relevant data to the model to build this model and refine it over time.
I think, and these structures are, and these structures change. So it's actually awesome to think around how, companies like Grammarly, they are enabling it as using algorithms like NLP, and we are, using it in our daily processes. We are using it in our emails. We don't even sometimes realize that there's a Google Chrome extension of Grammarly going on, and I'm just correcting it, and later, okay, how well it was able to predict and tell me what was the right way to write a sentence, or maybe write an application, or maybe people applying to various places, they write and they use Grammarly for it.
True, and so very surprising things are like, how it checks plagiarism in large documents in a few seconds. That's another wonderful thing.
And that's the second point where scale comes into picture, and how does that scale work, where we have so many documents. And what I understand from this this main thing is the plan is like, if my understanding is correct, so there is a process where where documents are tagged, all the important words. So a very basic algorithm which I had learned some time back was TF-IDF, right? So where you get certain important words, you tag documents to certain words, and then finally those tags are used and fed fed back into, whenever I want to validate an algorithm, I type it down, and Grammarly again goes back to those documents and first. And that's where I think NLP also comes into the picture, because if I have an overview of some data, right, it would make more sense for me to actually go and check that whether the data is actually making sense and data, and it has any matches or not.
So your TF-IDF basically looks into two components. One is what is the frequency of a particular word in a document, and then how many documents actually these words are occurring, and then goes by some kind of calculations for finding out the relevancy and the ranking of these words.
Right.
But there are many other techniques. It's not just TF-IDF. You have a lot of other back of word techniques.
Got it. Right. So that brings this aspect to a close. Finally, we have a few last questions, right? So the first, the question over here is: so we understood words, and we understood about how words are being read and how words are being analyzed. So we also have where what I understand is and tools like Google Translate, right? And text to speech, Alexa is basically where it is reading a speech and converting it into text, right? So that's where I think one key thing which comes to my mind is we have people who are have various ways to speak. Like even if we go from a region A to region B, right? Like if I talk about India, even if we speak Hindi is spoken in a different way, maybe in Bihar or in UP, right? So my very basic question is how does these tools like Alexa and the algorithms behind Alexa, how is it able to accurately identify that people with different accents still the word is correct? What is the basic logic around it?
Answer to this question, the first thing that I should say that there are a lot of research going on in this field, and if you see even Google Translate, it is not 100% correct.
Yeah.
Right. So this is still in nascent stage. First thing, though a lot of advancements have happened, but human language is a very, very different thing, right? The way you speak, the way I speak, forget about region. If you and me are from the same region, the way you speak, the way I speak is different. The meaning of the sentence differs with a simple punctuation, right? So all of this combined, a lot of research is going on. In fact, I know there is a research going on Indian names to identify whether it is a male or a female. And I know we can name some geography where you find names which you and me might say, oh, these are male names, but actually these are female names, right? So and so coming back to the point, yes, this is one thing. And second thing is, if you have noticed, like when you buy a new phone, you basically train the phone with certain words. You keep on speaking repeatedly, and that is how it captures your tone and your voice and the way you pronounce a word and all this. And then it trains itself to say, okay, this is the person who is talking to me now. Right. So it starts understanding the way you speak.
So basically, what I understood is it's basically a process, and it's all around taking the data and building the model over time, and
Yes.
understanding the nuances around it, and that's where it comes into picture. So I think we are done with all the questions for today. So thank you, Dipayan, for taking out time. And I have so we just had a course in Masters Union where Dipayan took a course for us on Python, where we understood data analytics and how to read data and how to play around with data. And it was a I thoroughly enjoyed the sessions with the Dipayan, and looking forward to having his sessions in future as well. So thanks all attendees to join in and share your questions. I hope you liked the webinar and you got to know certain nuances of natural language processing and how it is being applied in various industries. And it was insightful for you. It was very insightful for me. I thoroughly enjoyed it. Thanks, Dipayan, for taking out your time
Thank
and
you.
having this session.